Hello. So I made a video in the past about how to rotate a box, and a user who I would mention your name, I just don't want to because I'm not sure if you wanted me to or not, and I'll leave it up to you whether you want to like put in the comments below if you want to mention yourself, but I just don't want to like say your name or your YouTube handle, whatever, if you don't want me to. So I'm just not going to do it. But let's start off. So I was trying to explain what a perfect circle. So this isn't going to be exactly perfect, but I mean, you have to think of it like for all I just spit on my tablet. Great. For all intensive purposes, let's just assume that this is a perfect circle. All right? I mean, clearly it's not perfect because I'm not the best at drawing ellipses. But the important thing here to know is that this is like a perfect circle and like from like straight on. Different objects behave differently. Like if this was a ball, pretty much no matter what angle you look at it, it's going to be like, when from your perspective, it's going to be a circle, even though you can kind of understand that like no matter how, like, you know, if you look at it from the top, bottom, left, right, even like through like a weird angle, it's always going to be a circle. Now let's take a cylinder, right? Okay, let's say we're like looking at like a can of soup. So we got a can of soup here, right? Okay, we're looking at it like from above. Like let's pretend like this is like a can of like Campbell's soup, if you're familiar with that. You know, let's say it's chicken soup. I'm going into far too many details, but like we're looking at it directly from above. But the reality of the can, if you were looking at it from like a different perspective, let's say this is the horizon. I'm just drawing like a horizon line, and you know here, you know, if you think of a can at all, and let's say like the can is like pretty much aligned with the horizon. So we have like a top of the can, and we have a like bottom of the can of the soup. So like, you know, pretty much like a can of like soup or whatever, you know, it's basically like a cylinder. The important thing here to know is like pretty much like at the halfway point in this area, you wouldn't see the horizon through it. Let me just erase a portion of it real quick. Ugh. But in short, if you're looking at like a can of soup, like this is like what you would see. And the way it maps is like before, when we were looking at the can here directly above, this top plane, this is a top plane. Okay? And basically our top plane is actually here. Because if you think about this, like if you think about this ellipse here, you know, the ellipses, that is like, it's like a perfect circle, and how you see it in perspective is how it changes. Like it's still like a perfect circle. So if you would think of it like, let's just do a dotted thing here, but like you could think of it like this, right? Pretty much when the way you change perspective, you're going to see like a different degree of the ellipse. So like, you know, pretty much, even though I kind of cut it off, like I didn't show it in this image here, you still, like the ellipse is there. It's just like, because you're looking at it straight on, it's pretty much like just a line. But the reality is, even though you're seeing it as a line, it's still like an ellipse. Like this is a greater degree ellipse that I just drew, but the important thing to note is like how you look at it is like how it changes differently. And you know, the other thing is, because we're assuming that this can of soup is a perfect cylinder, you know, the top and bottom are both perfect circles. Even like the top here, like yeah, the top's a perfect circle, but also like the bottom's a perfect circle. Because if you would kind of like picture it, there's always like some type of circle here. Because the important thing to think is like, no matter, well, I guess when you're looking at the can, there's always like, you could think of it as like a bunch of different cross sections. So I guess I have to kind of correct myself, because when you're looking at a soup can here, I believe the perspective kind of does change. Wow, so I may have made a mistake here. But like here, like when you're looking at it straight on, you could think of like this whole cylinder. You could think of it as like a whole wide array of ellipses like contained within it. Like every section making up the cylinder is like is a different perfect circle making it up. I mean, you know, it's not sheared at all. So like because of our perspective here, I believe it actually would kind of be like that. Kind of 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 like that. So the important thing to note is you kind of have like pretty much, I'm just going to draw dots here. You pretty much have a bunch of perfect circles making up the can. Because it's like composed, I mean, I guess you could say it's composed of two-dimensional shapes. I'm not sure if that's maybe the best way to think about it. I wanted to go into depth about another thing. So like, please excuse my poor example. I hope I'm explaining this okay, but let's go to a box for a second, and I wanted to talk about how a box rotates, right? So here we are. And let's say we're looking at a, let's say we're looking at like, okay, let's say we're looking at the top of a box, okay? Like we're above looking down on a box. If you divide the plane of the box, you know, if you do that, draw two lines, you can find a center point. So what you can kind of do with that, if you like put it, well, no, let's do this. This is like this whole top plane that we're seeing is like the top of the box. And let's put it in perspective, okay? And it's kind of like pretty much hitting the vanishing point in this case. And like, you know, this is because we're like, before we were looking like over here, we were looking at the top of the box. Here we're kind of like looking at it when it's like aligned with the horizon. But the important thing to note is that this box here and this box here, it's still a box with 6 sides. So let me show you. I'm gonna draw another box here just to kind of like help maybe try to hone in the example. Okay. For this point, I'm just gonna kind of wing like the sides. I should probably do the old way. But the important thing to note is that it's a box and it has 6 sides. I'm going to show you those 6 sides to help. And this method to kind of imply vanishing points is what I learned from Drawbox. It is not, you just have to like kind of think about the planes in like 3 dimensions, which can be a bit difficult at times. But the important thing is to always be like thinking in 3D. Okay, so here we have a box, but I'm gonna put the where I think the other sides of the box would be. I'm just kind of winging it here. And I am drawing a bit small and I'm not rotating my page. Usually I would rotate my page, but I'm being lazy. I'm probably making a lot more awful mistakes than I should. Okay, so look, we have a box. Now, let's say this is the first side, and you kind of have to think of it differently, but like this is the back of the side. This is like the back side. So we have a bottom here. Like you can't see it. You can't see this bottom plane here, but that's 3. We're seeing like the front here, which is like 4, 5, and like this is going to get a bit weird, but it's 6. So what I'm going to do is I'm going to show you how those planes map again with a better way. Okay, so we have 1 here, right? This is 1. This side right here is 1. This side, which like isn't visible because it's kind of like hidden behind, and because of our perspective we can't see it. You could think of like this whole side is 2. This side is 3. This side is 4, but like I said, the side that's 4 is like the back of the box that we can't see on our perspective, but I kind of drew through it to try to show it. The bottom plane here, which is 5, we can't see that either based on our perspective because of the way we're looking at the box, but it's still there. And 6, we can see this, and this is like the top of the box, which kind of like maps to like that top, to like the top of the box when we were looking at it from the top. Okay, so now I'm going to undo those numbers real quick, and I'm going to show you something really cool. Okay, so here we have a box in perspective, right? I'm just going to do that, and we have like a center point here. Do that, and we have like a center point here. So if you draw a line that like pretty much goes through the box, through the like the center of the top plane and the bottom plane, you could think of that as like the axis of rotation, right? We pretty much have like a way to rotate the box in 3-dimensional space. Because like think of it how it would like pivot. Like imagine if you like had a, I guess you could say like a Jello cube, and you put like a toothpick through the center of it. If you like, pretty much if you like rotate the toothpick, you could like play with it. So this this box here, we're not looking at it like on it. This is not on the horizon line, but let's go back to this one that's on the horizon line. So if we put a toothpick through it, if we use like let's say this box is the same as that one, and we put a toothpick through it, right? So it would be right through the center, and I guess you could say because of our perspective, you wouldn't be able to see it in the same light. All you would see is like the top half and the bottom half, because I mean, I guess you could do that, but it's just a bit confusing. But the important thing to know is that it's crossing through the top plane of the box and the bottom plane of the box perfectly in the center. So if you were to like rotate it, you would modify like how it would look. Like to give a rough example, let's say we rotated the box a bit. So I'm trying to think of how to best do this. Well, I guess it would kind of be like that. If you would do like a larger rotation of it, no, that wouldn't really fit with the perspective. It would be more converging. I'm sorry, it's a bit difficult for me to visualize, but the important thing here to know is that you kind of have to visualize how it would be rotating in 3D space, even though it's kind of like a bit more 2D. So actually, what I'm going to go back to our toothpick example. I'm going to show you one other thing, right? So because of the way this box is sitting in space, I'm forgetting the method how to do this perfectly, but you could think of it like this, right? Before we talked about the 6 sides of the cube, or box, just because we're looking at this box in a perspective, those 6 sides are there. as hard as they are to see, they're all there. It's just like how you look at it. That's like how your perspective changes. So like the front plane here, that's like all we can see right now. We can't see any of the other 5 sides because we're looking at the cube straight on. But you still have the top plane. Sorry, you still have the top plane. You still have a bottom plane. You still have the left side. You still have the right side, and you still have the back side. They're all there, but you just can't see it because it's in perspective. So they still exist. Like, they exist in 3D space even though you can't see it based on how you are looking at it. And because we have like the horizon line here, that's kind of what makes that's kind of what changes it. Like when you change the horizon line, or like, well, the horizon line doesn't really change. Basically your perspective of it will change how you look at the actual box, but like everything's still there. So let me try to think for a second how to rotate the cube the best way. Okay, I'm just going to do this a bit exaggerated. It's like extremely exaggerated, but the important thing to note is that it's going to be just very subtle, I believe, if I'm doing this right. I'm probably messing it up, and there's probably like an exact technical way to do this. If I was going to suggest anything, I would maybe try to make some type of video yourself and try to capture it in like the correct perspective. But here, I'll draw an example because I think this is the best way to do it. I think another important thing is just to always have like some type of reference or try to find some type of reference. I think if you are going to use like a CAD program to do it, go ahead. Okay, so I'm going to draw the toothpick back again. And just to say this toothpick, let me do that again for you. The toothpick is still going through like the center of the top plane and the center of the bottom plane, so it's like still there. And even in the example I just drew here to the right, the important thing to note, there are still 6 sides, no matter how you turn it. I'm actually going to draw those too. I'm trying to think of how to best do this. This method that I'm using to try to imply the vanishing points I learned from drawbox.com. So if you want a really good way and probably a better explanation of how to draw boxes and how I'm doing it, I would definitely go there for it. Because I'll be honest with you, I have some experience, but like, how do I compete with someone who's been doing it for as long as I'm comfortable and the other people who do it? And the other art instructors, it's difficult because I don't, like, I draw mostly for fun and to get my ideas out of my head, and I don't do it for a living. I probably like to. It's always fun teaching people this stuff, and I also do have fun drawing it all. It's a treat when I get it to do it. Okay, so I just drew all sides of the box. Now let me show you how they map again. Just to say, that's the horizon line still. Like, you could just think of them how they're all lining up with their horizon. I tried to do it to the best of my ability. Just to reiterate, like, you know, horizon line, think of like the sun. Like, the sun is rising on the horizon, and it's kind of like that. Pretty cool, right? Okay, so let me show you how these sides mapped. Actually, let me draw the toothpick back in it, okay? So here and here, we still have the toothpick. Here and here. So the toothpick is going to like cut through there. I mean, still going through the top and bottom plane. It's still there. And I'm going to say because let's say we rotated this cube here. We rotated it with a toothpick to the right. So this is like side 1. You know, I'm trying to show you how they map. So this whole one is side 1. Side 5 is invisible to us, but that's like this one over here. Side 6 still isn't visible to us because that was the back one, but because we did the rotation, it's just like still not visible to us based on the perspective that we're looking at it. The difference here is 4 is actually going to be here. So the side that wasn't visible to us before, 4 is, you know, the bottom plane, which is number 3, still isn't visible to us because, you know, we're just still looking at the box perspectively, so that side's not going to be visible, and neither is side 2, because, you know, we can't see the top and bottom plane from our perspective, but they are still there. I think I got all of the sides. So yeah, basically here we pretty much did a rotation. I'm trying to think of a good way to draw this, but we rotated it like to the right. Yeah, that's a good way. Just a little arrow, a little corkscrew arrow to show how we rotated it. So it's just, you know, the whole thing rotates because it's on a toothpick, and that's kind of how it goes. Now let me show you another interesting thing. If we're going back to our cylinder example, if you were to I'm gonna wing it. We have our cylinder here. So a cylinder is a bit of a weird case. If you had a circle, and I'm just assuming this is the perfect center, let's just assume it. It's probably way off. If you had like another type of technical tool, you can probably do it. There's another one called Lazy Nizumi that can help you draw perfect circles. But let's say we put a toothpick through there. Okay, so we put a toothpick in the center of the top and bottom ellipses, circles, perfect circles in this case. Just assume that they're perfect. So when we rotate this cylinder to the right, kind of what we did below with the cube here, you really can't see the plane changes because like it's a cylinder, so it is rotating when you do rotate it, but nothing's really changing because you're not seeing any plane changes. Like the cylinder is definitely moving. Okay, like it is. You just have to go with that. But unless you like put like a drawing, like let's just say the letter T was on here, and we did decide to rotate it. For all intensive purposes, I'm really winging it here. But like, basically, when you are rotating it, it is moving, and if you like map a letter or some like shape to the curvature of the cylinder when it's rotating, the T like will start to disappear because you're rotating like that side. It's hard to say. I don't know the technical term for like, what do you call that curvature part of a cylinder, like this part. I don't know what you call that, because it's like, it's not a plane, it's not a circle, but it's like this. It's kind of like a marshmallow. Wow, I don't know how to describe it. I guess you could just say curvature. I guess it's just trying to like say, like, you know, obviously like a ball, like a bouncy ball doesn't have a side. It just has like a curvature to it. I'm pretty sure there's another math term for it, but I don't know that off the top of my head. If I did, I would mention it. But I hope this gives some clarification to you about like the top and the bottom and the whole aspect of it. But yeah, if you have another question, please ask and I'll try to answer it. Thank you.